To determine the minimum dimensions for a pull box with multiple conduits, we'll follow a step-by-step calculation based on the National Electrical Code, or NEC. Firstly, we need to determine the total cross-sectional area of all the conduits. In this example, we have 9 3-inch conduits, and each conduit contains 3 500 kc male conductors. We need to determine the cross-sectional area of each conduit. For this calculation, we are using 2.83 square inches as the cross-sectional area for each conduit. This value is based on the assumption that each conduit contains 300 kc male THHN conductors. Note that you need to verify the actual conductor size and type in your specific situation and use the corresponding cross-sectional area for an accurate calculation. With that, the total cross-sectional area of all conduits is calculated by multiplying the number of conduits, which is 9, by the cross-sectional area of each conduit, which is 2.83 square inches. This gives us a total cross-sectional area of 25.47 square inches. Secondly, we calculate the minimum dimensions of the pull box. According to the NEC, the minimum height of a pull box for multiple conduits is determined by the square root of the total cross-sectional area plus 6 inches. The minimum width is equal to the height plus 1.25 inches per conduit. Thirdly, we plug in the values we have determined to determine the values. The height, h, is equal to the square root of 25.47 square inches plus 6 inches, which equals 11.4 inches. The width, W, is equal to 11.4 inches plus 1.25 inches per conduit, which equals 26.79 inches. In conclusion, the minimum dimensions for the pull box are a height of 11.4 inches and a width of 26.79 inches. Remember, these are the minimum dimensions. You may need a larger pull box depending on the specific installation requirements and the physical layout of the conduits. Always refer to the latest version of the National Electrical Code, or NEC, and consult with a qualified electrical engineer or inspector to ensure compliance with all applicable regulations. In addition to the height and width, the depth of the pull box is also an important consideration. The NEC provides guidelines for the minimum depth based on the size of the conductors and the distance between conduit entries. The depth should be sufficient to allow for proper bending and pulling of the conductors without exceeding their bending radius. When determining the size of a pull box, consider the ease of installation and future maintenance. A larger pull box may provide more working space, making it easier to pull conductors and make connections. It can also simplify future modifications or additions to the wiring system. The NEC also addresses the material and construction requirements for pull boxes. Pull boxes must be made of durable materials that are suitable for the environment in which they are installed. They must be adequately supported and secured to prevent movement or damage. The covers of pull boxes must be securely fastened to prevent accidental removal and to protect the conductors from physical damage. Furthermore, the location of the pull box should be carefully selected to provide easy access for maintenance and inspection. It should be located in a well-lit area and free from obstructions that could hinder access. The pull box should also be protected from moisture, corrosion, and other environmental factors that could damage the conductors or the box itself. In some cases, it may be necessary to use a larger pull box than the minimum size required by the NEC. This may be necessary to accommodate a large number of conductors to provide adequate working space or to meet specific installation requirements. When selecting a pull box, consider the manufacturer's specifications and ensure that it is listed and labeled by a recognized testing laboratory. This indicates that the pull box has been tested and meets applicable safety standards. It is also important to follow the manufacturer's instructions for installation and use. Improper installation of a pull box can create safety hazards and may violate the NEC. When pulling conductors through a pull box, use appropriate pulling techniques and equipment to avoid damaging the conductors or the box. Lubricate the conductors to reduce friction and use a pulling rope or fish tape to guide the conductors through the conduit. Avoid pulling the conductors too hard, as this can damage the insulation and create a potential safety hazard. After the conductors have been pulled through the pull box, Carefully arrange them inside the box to prevent them from becoming tangled or damaged. Use cable ties or other fasteners to secure the conductors and keep them organized. Ensure that the conductors are properly identified and labeled to facilitate future maintenance and troubleshooting. Finally, inspect the pull box and all associated wiring to ensure that everything is properly installed and in good working order. Check for any signs of damage or wear and tear and replace any defective components. Test the wiring to ensure that it is properly grounded and that there are no shorts or open circuits. By following these steps, you can ensure that your pull box installation is safe, compliant, and reliable. Always consult with a qualified electrical professional if you have any questions or concerns about the proper installation of a pull box. In addition to the NEC requirements for pull box sizing, there are also specific requirements for the spacing of conductors within the box. The NEC specifies the minimum distance between conductors and between conductors and the walls of the box. These spacing requirements are designed to prevent overheating and to ensure that there is adequate room for splicing and terminating the conductors. When selecting a pull box, consider the number and size of the conductors that will be installed in the box, as well as the spacing requirements of the NEC. Choose a box that is large enough to accommodate all of the conductors while maintaining the required spacing. The NEC also addresses the issue of conduit fill. Conduit fill refers to the percentage of the cross-sectional area of a conduit that is occupied by conductors. The NEC limits the maximum conduit fill to prevent overheating and to ensure that there is adequate room for heat dissipation. When selecting a conduit size, consider the number and size of the conductors that will be installed in the conduit, as well as the conduit fill requirements of the NEC. Choose a conduit size that is large enough to accommodate all of the conductors without exceeding the maximum conduit fill. In addition to the NEC requirements, there may also be local codes and regulations that apply to pull box installations. It is important to check with your local building department or electrical inspector to determine if there are any additional requirements that must be met. Local codes may address issues such as the type of materials that can be used, the location of pull boxes, and the grounding requirements for electrical systems. Failure to comply with local codes can result in fines or other penalties. When installing a pull box, it is important to take precautions to protect yourself from electrical shock. Always disconnect the power supply to the circuit before working on any electrical equipment. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Use insulated tools to avoid contact with live electrical conductors. If you are not comfortable working with electricity, hire a qualified electrician to perform the installation. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. In addition to the safety precautions mentioned above, it is also important to be aware of the potential hazards associated with working in confined spaces. Pull boxes are often located in confined spaces, such as attics, basements, and crawl spaces. These spaces can be hazardous due to limited ventilation, poor lighting, and the presence of asbestos or other hazardous materials. Before entering a confined space, it is important to assess the potential hazards and take appropriate precautions. Ensure that there is adequate ventilation, use appropriate lighting, and wear a respirator if necessary. If you are not comfortable working in a confined space, hire a qualified professional to perform the work. Working in confined spaces can be dangerous, and it is important to take all necessary precautions to protect yourself and others. When selecting a pull box, consider the environmental conditions in which it will be installed. Pull boxes that are installed outdoors must be weatherproof to protect the conductors from moisture and corrosion. Pull boxes that are installed in hazardous locations must be explosion-proof to prevent explosions in the presence of flammable gases or vapors. Choose a pull box that is designed to withstand the specific environmental conditions in which it will be installed. In addition to the environmental conditions, it is also important to consider the potential for physical damage to the pull box. Pull boxes that are installed in areas where they are likely to be struck by vehicles or other equipment should be protected by bollards or other barriers. Pull boxes that are installed in areas where they are subject to vandalism should be secured with locks or other security devices. Choose a pull box that is strong enough to withstand the potential for physical damage. When installing a pull box, be sure to properly ground it to prevent electrical shock. The NEC requires that all metal pull boxes be grounded to a suitable grounding electrode. This can be accomplished by connecting a grounding conductor from the pull box to a grounding rod, a metal water pipe, or another approved grounding electrode. Ensure that the grounding connection is secure and that it meets the requirements of the NEC. In addition to grounding the pull box, it is also important to ground all of the electrical equipment that is connected to the pull box. This includes the conduits, conductors, and any other metal enclosures. Grounding the electrical equipment provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. When making connections inside a pull box, use approved connectors and terminals. The NEC specifies the types of connectors and terminals that can be used for different types of conductors. Use connectors and terminals that are properly sized for the conductors being used and that are rated for the voltage and current of the circuit. Ensure that the connections are tight and secure to prevent overheating and arcing. After making all of the connections inside the pull box, inspect the wiring to ensure that it is properly installed and that there are no loose connections or exposed conductors. Use a multimeter to test the continuity of the circuits and to check for any shorts or open circuits. If you find any problems, correct them before energizing the circuit. Finally, label the pull box to indicate the circuits that it serves. This will help to prevent confusion and to make it easier to troubleshoot problems in the future. Use a permanent marker or a label maker to create a clear and legible label. Attach the label to the outside of the pull box where it can be easily seen. By following these guidelines, you can ensure that your pull box installation is safe, compliant, and reliable. Always consult with a qualified electrical professional if you have any questions or concerns about the proper installation of a pull box.